All right, and we're live. Let's get started. We got 16 questions. Wow, y'all did real good at first. Then it just kind of tapered towards the end. All right, let's see what we got going. A switch is designed to safely allow and interrupt the flow of current. So, switches let current through. It's pretty straightforward. The number of actions that allows us to close the switch is referred to as the throws of the switch. Let me move this up here. So, the throws of the switch. Let's, alright. The pin. So, we've got a single pole switch. I'm going to draw that for you. So, we have two conductors and the switch. Let's just grab a different color. Well, we won't have a different color for this one. This is a single pole, single throw switch. So, in other words, this switch only controls one circuit, and it only has one position that it is allowing current through. Contrast that with a single pole double throw switch, which has one circuit that it's making or breaking, but it has two positions that it can go into to allow current flow. I'm going to scoot a little bit. That's better. All right. So, this is also known as a three-way switch. So, single pole double throw is also a three-way switch. And going the other direction, a double pole single throw. Alright, this is two poles, so you can have 240 volts. This would be a switch that can control two hots. So you have two legs going in, and one switch flip. That's what this dotted line means. That means they're interlocked, and they both flip at the same time. You hit one switch, and it makes and breaks both legs at the same time. So there's only one position that it can allow current flow, but it's controlling two circuits. I'm still getting used to where the camera can see me. So I'll be like making hand signals like down here. And like, I'm like, yeah, it's right in front of the camera. But like, the camera's like right above my hand. So I apologize if I'm like waving my hands around wildly and y'all can't see it. Alright. Next up, a circuit that is drawn on paper. So this is a schematic. These were schematic ways of drawing switches. The term blank, let's see. Okay, the term short circuit. This would be whenever you have a circuit drawing So this would be a circuit. A short circuit would be where the current bypasses the load. What type of circuit has no current flow through it? That'd be an open circuit. So this, what I drew, is actually an open circuit. I did not close the switch, so it's an open circuit. Had I closed the switch, that would be a closed circuit. Single pole switch, we covered that already. Two switches are used to control a light load from two locations. So two three-way switches would be used to control a light load from two locations. What we're doing with three-way switches is you can put them at, like if you have multiple doors entering a room, you can put a switch at every door and control the lights from all the locations. A single pole double throw switch is also known as a three-way switch. Covered that earlier. In the United States, electrical conductors are most commonly sized to the dimensions of the American wire gauge. Calculate the resistance of a piece of copper wire with a diameter of 16.2 mils. Okay, so this is going to be chapter or lesson 4 now. Let's open up. Let's Control A, delete. Okay. So the formula here, and I would write this down in my code book if I were you. We're on the page. This is going to be R equals K times L. K times L divided by area in circular mils. So, go back to our question. Diameter of 16.2 mils and a length of 15,840 feet. And copper is 10.4. So let's put our numbers in. $10.4 times 15,840. And then we need to get the area in circular mils. We can't use, what was it, 16.2. The 16.2 isn't quite there yet. So, area in circular mils is equal to the diameter in mils squared. I do not have good posture teaching hunched over like this. Oh. Alright, are we back? It looked like I had a lost connection for a second. So I'm going to keep going. But it looked like we had a hiccup. I apologize. Alright, so the diameter in mils squared, that would be 16.2 squared is equal to 16.2 squared is equal to let's see, 262.44. YouTube is not receiving enough video to maintain smooth streaming. As such, viewers more info will experience buffering Okay, I am going to give me 1 second. I need to maybe adjust some things. I haven't had this issue yet. Um, hmm. Okay, it says excellent connection again. After this video, I will see what's up. I might restart my modem and stuff. But I think we're good again. If not, I will. The video's going up afterwards. Maybe you'll just be able to rewatch it later. Okay, so let's plug our numbers in. 10.4 times 15,840 divided by 262.44. 627.7. 620. Okay, good. Uh, it was throwing up some errors for me, so I'm glad that you guys seem to be better. It's that Warren internet. I'm not actually in Warren, I'm in Beaumont, but you know. Alright, cross sectional area. So American conductors is expressed in circular mils. Explain how to calculate approximate. So this is mils. That mils number that we talked about is mils is milli inches, or a mil is 1,000th of an inch. To help you visualize it, you can imagine like trash bags and like yard bags and plastic sheeting and stuff. That is a example of something commonly measured in mils. So if you went and bought some drop cloths to paint your house, they would be you would buy it by the thickness in mils. The more mils, the thicker the cloth is. So to get mils from inches, so like a 1/2 inch thing, so a half-inch piece of wire would be 500 mils. You take inches. Inches times 1,000 will be your measurement in mils. Alright, so this is that same, and I will work through this. Aluminum, to find the K value for aluminum, you have to go in your book. It is 17.7. I believe that is on page 70, no, 74, 94. It's on one of the fours. Less than 100. I want to say it's 74. Yes, it's 74. I found the thing that was in the 90s. Yes, so 74 is where the K values are at the certain temperature, which is 68 degrees Fahrenheit. So 100 mils. So that's 10,000. 100 squared is 10,000. So R equals 17.7 times 10,000. Oh, I want to say, I'm going to do the math. 5,280 times 2. 10,560. 17.7 times 10,560 divided by 10,000. So you plug that number in, and you will get 18.69. That's going to be the answer. What is the approximate gauge of a wire that has a diameter of about 100 mils? It's number 10. If you turn the page back one to page 73, they have a chart. It is also in Chapter 9, Table 8 of your code book. And that chart will tell you, based on the size of the wire, what the gauge of that wire is. So you can just go down that column in circular mils and find the 10,000 circular mil wire, and that's number 10 is the closest one. The resistance of a specified length of wire of a certain type is directly proportional to its blank and inversely proportional to its cross-sectional area. Specific resistance. So it's specific resistance is the K value of the wire. Yeah. Specific resistance is also called resistivity. Okay, yeah. And is the K value. All right. If you have any questions, feel free to contact me on any of the any number of places. I'm going to put up the new. So this was 3 and 4, so I need 5. Lesson 5. So there's lesson 5, and y'all are good to go on that. I will see you guys in 2 hours. So 3:45. Don't end the current activity. End the stream, John. I'll see y'all at 3:45.